Dynamic is a good word to use to describe Mars. We've heard stories of awe-inspiring events taking place there in the past. In the meantime, where did all of the planet's water go? As the sole other world in our solar system with surface water, something went wrong for this planet to diverge so sharply from its similarity with Earth. That world is a little like something out of a mystery tale. And it's there that Elon Musk has planned to construct a permanent human settlement using the huge Starship rocket. But first, groundwork must be completed. There are currently a number of scientific findings being made by NASA's Curiosity, Perseverance, and its tiny helicopter as they explore the planet. What did these rovers find out about the red planet? What impact will these discoveries have on Elon Musk's plans for a human metropolis on Mars? A metropolis on Mars has long been Elon Musk's goal, and he's been working on it for years. More than 1 billion people may live there, and the human race would become an interstellar species. It's impossible to comprehend the enormity of the cosmos, and it's expanding much faster than previously thought. Even though humanity will never be able to map out all of space, we continue to explore it nonetheless. As far back as the 1970s, humans have been sending unmanned vehicles and rovers to the red planet. Our understanding of Mars is greatly aided by these rovers sent by NASA and other space organizations. Understanding Mars is also critical for Elon Musk's Mars colony concept. The Curiosity and Perseverance rovers from NASA and the Zhurong rover from China are the only 3 currently operating rovers among the 6 that have ever successfully landed on Mars. It is currently too unsafe and expensive to send humans to Mars, so space organizations chose to employ rovers instead. Nobody knows for sure how long it would take a human being to return from Mars alive. Of course, nothing can be assured, but there is no easy way to address some of the risks people face while exploring Mars. These include the consequences of high radiation levels and variations in gravity, the isolation and confinement on the lengthy trip, the necessity to plan for any medical emergency or equipment failure, and how to provide enough food for the duration of the mission. Furthermore, robotic rovers such as NASA's Curiosity rover can last for hundreds of days or even years. More so, unlike rovers which do not require a return journey to Earth, every human manned space mission must be a round trip. Rovers can therefore collect more data with fewer resources and without endangering anyone's life than humans do on board, making them an attractive option for space organizations. Since August 6, 2012, NASA's Curiosity rover has been exploring the Martian surface. Among its goals was figuring out whether or not Mars formerly had the necessary conditions to support microbial life, which is why it was deployed. The discovery of sheepbed by the Curiosity rover suggests that the ancient Martian environment contained elements necessary for life, such as carbon, nitrogen, and phosphorus. Detection of methane gas by Curiosity's SAM sample analyzing at Mars instrument in the atmosphere of Mars could indicate the presence of life or high water content in the soil. More than a year ago, Perseverance and Ingenuity arrived on Mars. In the months and years to come, both vehicles will continue to carry out experiments that will further our knowledge of Mars and its environment. Perseverance is a rover based on the main architecture of Curiosity, but with its own unique capabilities and some characteristics that Curiosity lacked. Meanwhile, Ingenuity is the little helicopter that, in the spring of 2021, became the first human-built aircraft to travel on another planet. They collaborate to advance research. Perseverance and Ingenuity are dedicated to finding evidence of ancient life on Mars, and their goal is to do it in the most efficient and effective manner possible. The Perseverance rover is equipped with imaging equipment that can capture electromagnetic emissions, EM emissions from radio to hard UV as a means of accomplishing that purpose. Thanks to this equipment, the rover can make on-the-spot decisions about what's in the Martian regolith, rocks, and atmosphere. The scanning habitable environments with Raman and luminescence for organics and chemicals, Sherlock sensor, is one example of the imaging technology aboard Perseverance. Raman and fluorescent spectrometer Sherlock is a Bohr-sighted resonance spectrometer with a high spatial resolution. Radar imager for Mars subsurface experiment, RIMFAX, is another instrument. RIMFAX is on Mars to analyze the terrain beneath the landing site and to search for any remaining water ice that has not yet been sublimated. Montmorillonite clay has been discovered in the bottom of the Jezero crater. The weathering of silicate rocks in the presence of water results in the formation of clay. In the absence of ice crystals, clay serves as a strong indication that water was present at some point in the deposit's history. Crater lakes are evidence to have existed in Jezero's crater, which was fed by a river that branched out into a delta known as Three Forks on the crater's northwest border. Water is a critical component of the Mars 2020 mission, and Jezero was awash in the stuff. Water is life on Earth, and scientists believe that the earliest amino acids were formed in water that was rich in organic components. If there are signs of life on Mars, they're likely to be found in or near water. Because of the early life traces discovered in terrestrial lava tubes, Martian lava tubes are another promising candidate. In addition, we believe the delta is littered with boulders. When and how did they arrive? Only massive floods on Earth are capable of moving rocks of this magnitude. Using images and data gathered by RimFacts, Sherlock, and Watson, we can learn more about the geological history of Mars and the extent to which the planet was wet in the distant past. The Curiosity rover on Mars just returned a picture that highlighted an intriguing feature in the rocks of the red planet. It looks like an intricately carved entryway on the Martian terrain. Doppelganger doors are so convincing that they almost make us believe there is some sort of secret hideout for Martians or that there is a portal to another universe. This is also giving us tunnel to the center of the planet vibes. Science fiction movies could at least be inspired by this photo and the geological aspect it captures. However, it's far more rational to point out that this is most likely due to a shear fracture, which occurs when a strain on the rock causes a portion of it to break off, possibly with a helping hand from a Mars quake or two. In fact, the greatest tremblor ever recorded on Mars occurred on May 4th this year, and scientists are still trying to figure out what caused it and where it was located. Furthermore, while the door-like rock formation may appear to be life-size in our imaginations, the cavity seen in real life could only be a few centimeters or inches tall, though it's difficult to tell from the image. Close-up images of Mars from rovers and landers have shown a fascinating variety of the red planet's geology, including ice-filled craters, chevron-shaped rock formations, hollowed-out mountains, and more. But it's vital not to get carried away with what hazy photographs could suggest when it comes to eerie space discoveries that resemble alien buildings. You may recall China's Yutu-2 rover spotting a strange cube-shaped object on the moon last year. Further study revealed that the alien home was actually just another rock, given its cuboid shape by light and perspective effects. In light of what Curiosity has discovered most recently, this is a possibility. On Mars, Ingenuity began its illustrious career as a technology demonstration for rotorcraft flight in a low-pressure environment far below that of Earth. The density of Mars's atmosphere at surface level is about 1% that of Earth's atmosphere at sea level. In comparison, the all-time helicopter altitude record on Earth reached 40,820 feet, which is near the top of the passenger jet cruising altitude range. Earth's air is 30 times denser than Martian STP standard temperature and pressure, even at that altitude. Piloting Ingenuity is thus not only a first for aerodynamics, but also a game-changer for off-world exploration in general. Being able to fly around on Mars brings up a whole new set of options for exploration beyond simply making the record books. Elon Musk's vision of a human colony on Mars has inspired NASA to explore new ways of finding and solving problems in order to gain momentum in the second great space race, the commercialization of low Earth orbit and the expansion of human influence into the greater solar system, especially on Mars. 2 cameras on board Ingenuity enable high-resolution observation of its surroundings, in addition to being the pilot project for powered flight on another planet, a 13-megapixel color camera with stereoscopic imaging, and a downward-facing black and white camera for use in navigation. In addition, Ingenuity is acquiring enough data to create a high-quality 3D map of the Martian landscape between the 2 cameras it has on board. We can now map the Martian landscape to the individual rocks thanks to stereoscopic 3D and the repeated photographing of the surface at different times on different sols. As recently as a few years ago, we didn't even know if water existed elsewhere in the universe. We now have a small population of robots on another planet searching for traces of life and squinting into the soil to see if there is water there. This is useful for a variety of legitimate, important, and well-founded scientific reasons. Elon Musk's plan to establish a colony on Mars may be closer than we previously thought.